So this question is coming from FebMart 17, paper 3, variant 2. And this is the fifth question of that paper. We are given the equation of the curve, as you can see on the screen, where two functions are multiplied, where a, which is present over here, is a positive constant. And this is going to have only one point in the interval of 0 to pi by 2, at which the tangent is parallel to the x-axis. So there might be a curve like this. We don't know how exactly the curve is going to look like, but we can still take an idea. Let's say over here somewhere is 0, over here somewhere it is pi, and in between that there is only one point where the tangent to the curve is parallel to the x-axis, which means the gradient of the line is equal to 0. So from here what I can do is I can differentiate this equation and say that it is equal to 0 because gradient is nothing but your dy dx. So this is the initial idea that I'm having. Now we are supposed to find the value of a and state the value of x coordinate of the point. We have to state the exact x value of that point. So let us go ahead and try to solve this with the idea that we have mentioned over here and see where we end up. So clearly we can see that it's a u into v format. So we can apply a product rule. In the first question, we have applied the quotient rule. So yeah, let's see how it's going to work out for us. Y is equal to e to the power of minus ax, that is multiplied with 10x. Now, if you differentiate this dy over dx with the help of a product rule, what is a product rule? If we are having uv that you are trying to differentiate, you differentiate the first function, keep the second function as it is, then add with the differentiation of the second function by keeping the first function as it is. So if I apply this rule over here, let me just highlight it on the side. So if I implement this, if I differentiate this, it will become minus a e to the power of minus ax, keeping 10x as it is. And then the differentiation of 10x is sec square x. And along with that, I need to keep the u term as it is, as you can see in the formula. So e to the power of minus ax dot sec square x. Now I know that dy dx has to be equal to 0. Dy dx is equal to 0 for tangent being parallel to x-axis. So from here, if you have seen the previous video, I have told you whenever you get this kind of terms, you take the common out. That is the first thing you do, and then you try to simplify it further. So if I continue, it's going to become, let's say, e power of minus ax is the common factor, as we can clearly see over here. So e power of minus ax, let me write sec square x in the terms of 10x. I know that sine square plus cos square is equal to 1. And if I want to get a sec x square, sec square x can be done by getting a cos square over here. 1 by cos square is sec square. So I need to divide this by cos square, this by cos square. So that is tan square plus 1 is equal to sec square. If you remember the formula, that is well and good. I like to derive it on the spot. So you know that 1 plus tan square is equal to sec square x is what I'm going to write over here. 1 plus tan square x. So e power of minus ax is multiplied with this. And then you're also having minus a tan x over here. Now this is equal to 0. So clearly either e power of minus ax is equal to 0 or this quadratic in terms of 10, which is tan square x minus a tan x plus 1 is equal to 0. Now clearly we have to reject this because ln on both the sides will bring minus ax down, but ln of 0 does not exist. So this kind of thing is going to be rejected. We can't proceed over here. So let us proceed on the right hand side. So the question was to first find out the value of a and then state the exact value of the x coordinate. So how can we find the value of a given a quadratic? And it's also given that the equation of a curve and the tangent was parallel to the x-axis. It means there is only one point of intersection in that case. So what I can do is I can say that the b square minus 4ac for this quadratic will be equal to 0 because discriminant equal to 0 means there is only one point of intersection. So I can say that b square minus 4ac of this quadratic or a hidden quadratic is equal to 0, where the value of a is 1, b is minus a, and c is 1. So b square will become a square minus 4 times 1 times 1, which means that a square minus 4 is equal to 0, which means a square is equal to 4. And from here I can say that a is equal to either 2 or a is equals to minus 2. Now clearly in the question they had mentioned that a was a positive constant. And the moment I know that a is a positive constant, I can simply say that this is rejected. And I got the value of a is equal to 2. Now the moment I got the value of a is equal to 2, and there is only one value of x that we'll be getting because of this, so I can go ahead and continue and say that tan square x minus 2 tan x plus 1 is equal to 0. And if I try to solve this with the help of calculus, of course there will be only one root. That is how we got a is equal to minus 2. So 2, not minus 2. And then this minus 2 and 1. Yeah, x equal to 1 is the only solution. So I can say that tan x minus 1 the whole square is equal to 0. And this implies that your tan x is equal to 1. And from here you can say x is equals to pi by 4. If you do tan inverse of 1, it will become pi by 4. And that's the solution in between 0 to pi by 2. So this becomes answer for this question. This is the exact value that you got. X is equal to pi by 4 and a is equal to 2.